Okay, our topic for today is environmental risk assessment. Environmental risk assessment, or ERA, is defined as a field of study that attempts to understand events and activities that bring risk to human health or the environment. Now, ERA here has two kinds. The first kind would be the ERA that is being done right after EIA. Remember, I taught you how to conduct an environmental impact assessment. If it happens that after the EIA, it has been identified that the risk of the impacts are significant to humans as well as the environment, another process or another study will be done in continuity of the EIA. So this process is the ERA. However, the environmental risk assessment that I'm going to teach you today would be more applicable in the industry, in the actual industrial process. So before we proceed with how to conduct an ERA, let's define first what is risk. So a risk is a potential of losing something of value weighed against the potential to gain something of value. It's also referring to value or values such as physical health, social status, emotional well-being, or financial wealth. This can be gained or lost when taking risks resulting from a given action, activity, and or inaction foreseen or unforeseen. In short, based from the two definitions, this is actually a predictive process. So you don't know what you will gain out of, you know what you will gain out of it, but you don't know what will you lose out of it. So it's just like falling in love. You know there's a benefit of it, but you cannot quantify it, as well as you know you get hurt, but you don't know also how to quantify it. But since we are engineers, we will learn here how to at least predict the magnitude as well as the occurrence and the severity of this risk in a particular process. In our case, the different processes in an industrial plant. Now, the risk that we're going to, in order to do or predict the risk or to conduct the risk assessment, we must have a standard. Now, the standard for risk assessment is the OHSAS. This stands for Occupational Health and Safety Advisory Services. Now, the OHSAS is actually an international standard. So, if you would like to have a quality management system, you have an ISO 9000. If you want to have environmental management system, you have ISO 14000. In the case of OHSAS or OHS, you will have ISO 18000. But as I have told you in our lecture in environmental management system, in industry, what is being done is a 3-in-1 process. So the industry need not to be accredited first as ISO 9000, but nowadays the current trend is they undergo what they call integrated management system, wherein they can be accredited with ISO 9000, ISO 14000, and ISO 18000 at the same time, or in one single step. So on that note, if we're going to base it from International Organization for Standardization, or ISO 18000, risk is defined as the product of the probability of a hazard resulting in an adverse event times the severity of the event. So we will focus on these three categories: the probability, the severity, as well as the occurrence of the hazard. Now, the succeeding slides show you the first part on how to identify risk. The first part in ISO is the EHS aspect identification. If you're going to take a look at the process is exactly just like the diagram that you have used in life cycle assessment. So, if we're going to take a look at the box, you have at the box or inside the box the activities, and then as inputs, you may consider the raw materials or whatever chemicals are going to use for the process. This will also include water resources as well as the energy resources, especially if the process involves utilization of equipment. And then as you have learned in life cycle assessment, you can identify the final product that you want which serve as the output. But since there's no 100% efficient process as we have learned in LCA, we have to identify the different ways that will be emitted in air, in water, as well as solid waste. Now, after using this diagram, you will see from the figure that the form indicates the EHS aspect, plus you have to indicate whether you have a direct control or an indirect control of this. After identifying the aspect as well as whether you have a direct or indirect control of it, the next step is to identify the impact. Now again, this is where you can make use of what you have learned in LCA, that you can make use of the different global themes such as acid deposition, ozone depletion, global warming, as the general impact for air. In terms of water, you can identify aquatic toxicity, ecotoxicity, aquatic toxicity, as well as eutrophication. So you have to review the general theme. That will describe the aspect or the impact that each aspect would have. And then, after identifying, you take note that in the form, there's a specific control. Now, normally in industry, the specific control would be the procedure. So this form is actually based from a standard procedure of the company. Take note also that what we're doing is part of ISO accreditation. So if you would like to be accredited in terms of integrated management system, you can make use of this format. In risk assessment, you have to consider, based on the definition of ISO, you have to consider the probability, the severity, as well as the occurrence. Now, there are several steps in order to do this, but of course, the first step is to identify the environmental aspect. So, in this slide, we have here a form that identifies EHS aspect in each process. So, in this form, you can see a diagram which is familiar to you. This is a pattern in our life cycle assessment wherein you can identify the inputs that may be used for a certain process. Inputs would include the raw materials, chemicals, water, as well as the energy that you need in order to run the equipment being used in the process. And then of course, in a life cycle assessment, we have the output, the desired product. But since there's no 100% efficient process, waste may be generated. Now from these waste, we can now identify the different environmental health and safety aspect. So this may be waste that may be in your wastewater. This may be solid waste, which can be further classified whether hazardous or not. And of course, this can be air emissions. Now, in this form, you can see that after identifying the EHS aspect based from the diagram, you have to identify whether you have a direct or an indirect control of this. Now, after doing so, you can make use of your general themes to identify the specific impact for each of these aspects. General themes such as global warming, ozone depletion, acid acidification for air emissions, eutrophication, aquatic toxicity for wastewater contamination, and then ecotoxicity or human toxicity in terms of solid waste or hazardous waste. The EHS aspect identification will be completed if you consider the conditions where the impact would happen. So for example, if there would be excess utilization of energy, then there will be global warming. So you have to have it enumerated in the third column. And then in the last column, there is the control or the control for each aspect in order to control the impact it would have. So for example, normally in industry, the control would be the procedure. So this EHS aspect is actually based from a standard procedure being followed by the industry. And take note class that this form is taken from an ISO manual of a company that would like to be accredited based from Integrated Management System. That's a combination of QMS, EMS, and OHS. Now, this form shows you a specific activity of a waterworks operation. So, this is actually cleaning of reservoir. So, in order for you to identify the aspects, the EHS aspect for cleaning reservoir, you have to enlist all the inputs that you need, such as chlorine, the equipment that you need to use to take off the sludge, and so on. And then after that, based on the diagram, we have to identify the different impacts in terms of air emission, wastewater contamination, as well as the solid and hazardous waste generation of reservoir cleaning. Now, we have, in waterworks operation, we have identified a procedure on how to conduct it so that we could minimize these impacts. Another activity wherein you can make use of, which is an example of EHS identification in waterworks operation, is the filtration operation. So again, we have identified the different activities being done, and then from here we have identified the different EHS aspects, and then we identified whether we have a control or a direct control or indirect control. So for example, in filtration operation, the number one impact would be, especially for backwashing operations, the number one impact would be the generation or the consumption of water for backwashing, as well as the generation of a lot of wastewater. So, based from this could have an impact on energy resource depletion. Why? In order for you to come up with the backwashing, you need pressure and gas, you need to use pump. And then, the filtration process, backwashing, would specifically generate some sludge coming from the clean filter, and thus this would be generation of solid waste. So, and other impacts have been identified. Now, after you have identified the EHS aspect, the next thing is to evaluate the EHS aspect. Now, we have another form, an ISO form to do this. Now, if you're going to scrutinize this form, you would see that the first half of the form, the second form, is actually a summary of the EHS aspect identification form, wherein, again, you have the different items, the different EHS aspects that you have identified per process, and then determining the control, whether it's direct or indirect, and then what particular activity area or equipment are you getting this aspect from, and then what are the impact of each of these aspects, and then what condition for this to occur or to happen, and then what existing control do you have. So again, this is just a summary of what you have just done in EHS aspect identification. But what's significant about this second form is the evaluation itself, wherein you're going to identify the regulation, the regulatory laws, or the regulations and laws that would address each of these EHS aspects, such as RA 8749, RA 9275, RA 9003, as well as RA 6969. Now, you have to determine whether the company is compliant or non-compliant with these regulations. And then, the last part, which is the most significant part of this second form, would be the risk assessment. Now, going back to the definition of what is a risk, it's actually the product of occurrence, the probability, as well as the severity of this risk to occur. Now, in this form, what you're going to do is you're going to involve a numerical value so that after multiplying these three parameters, you're going to have a rating, a specific rating. And then this rating will be compared to the ISO standard rating. And then you have to conclude. If it is higher than the ISO standard rating, that means you have to do something about the process to minimize the risk. So how would you evaluate or give a numeric value for the 3 parameters? You have to have your own rubric. Okay. So the next slide shows you the different ratings for the probability, the detection, as well as the seriousness of a particular risk. Now, who would be the source of this rubric? There's no one that can be a best source of this rubric than the process owner. Process owner would be you if you happen to be a process engineer, because you know already the in and out of the process, as well as in the first step you have identified already the different aspects using life cycle assessment. So based from this example of the rubric, you have here the rating, the numerical rating 5 as the highest and 1 as the lowest in terms of, as mentioned, detection, probability, as well as seriousness. But in some practices in industries, they have divided the seriousness in terms of environmental, health, and safety concerns plus the business concern. Because in ISO, they have what you call BCP or Business Continuity Program. Why? Because they have identified that most of these impacts that are caused by the EHS aspects can brought about haltering or stopping of this process. And of course, based from the principle of sustainable development, it would affect the profitability of the company. And thus, the seriousness would involve not only the EHS concern, but also the business concern. The 3 parameters that are involved in calculating risk in the form that we have discussed are occurrence, control, and severity. But in ISO, they have utilized another terms for these other terms for this OCS, occurrence, control, and severity. That is probability, detection, and seriousness. At any rate, whatever is the product of OCS, occurrence, control, and severity, would be considered also as the risk if you use probability, detection, and seriousness. So if you're going to multiply, looking at the form, if you multiply the occurrence, control, and severity, which is also equivalent to probability, detection, and seriousness, and you have found out that the product of each aspect would be equivalent to the RAR or even greater than the RAR. What's RAR? This is risk acceptable rating. Based from ISO, the RAR equivalent or value should be 12. So if the EHS aspect that you have identified would be corresponding to a RAR greater than 12, that means you have to go back to the procedure. Because remember, the EHS identification will be based from the procedure that the company has established. But if it is lower than 12, of course, since ISO is part of CQI, remember, CQI is continuous quality improvement, you can even make it low, the RAR or the risk acceptable rating. So that's our objective as environmental engineers. Now, after doing this inside the industrial plant, there are also some environmental scientists, environmental planners, and environmental managers that are still concerned about the risk outside the plant. So these would, the next steps that I will be discussing to you would be based from the era, the kind of era that is being done after EIA. You remember in the introduction. So what are the steps in risk characterization or in ERA? One is hazard assessment, followed by dose response assessment. Then you have to characterize the risk based from the exposure assessment. Take note that the hazard assessment and dose response assessment can be done parallel with exposure assessment. assessment so as to characterize after the risk. In hazard assessment, this table of hazard categories and examples of potential hazard manifestations can be utilized in identifying the hazard. There are four basic classification of hazards. We have human toxicity hazards, which includes carcinogenity, mutagenity, and any impact on humans. Another classification of hazard or another category is environmental toxicity hazard, which includes aquatic toxicity, avian toxicity, amphibian toxicity, phytotoxicity, or mammalian toxicity. The third category of hazard are physical hazards, or is physical hazard, which includes explosivity, corrosivity, oxidizers, reducers, the pH of the substance, as well as its reaction with water. And lastly, the hazard category is called global hazards. So these global hazards will refer to those environmental impacts that you have learned, such as acid rain, global warming, ozone depletion, and so on. Now, another diagram would help you to identify whether the human hazard is serious or not. So you have here a diagram that shows that if you just have a skin rash, cough, throat irritation, headache, or dizziness, this will fall under less serious. And normally, if it is less serious, it is reversible, not debilitating, and not life-threatening. On the other hand, you have more serious, irreversible processes, debilitating and life-threatening, when the substance would affect or would cause kidney and liver damage, can cause cancer, can damage the nervous system, or even can cause birth defects and miscarriages. So you have to determine whether the impact on health would be less serious or more serious. This can help you predict the value of the risk. Now, since we cannot do it by quantity, there is an estimation technique that is being used to estimate the risk. Now, if you're familiar with the terms such as LC50 and LD50, your LC50 means lethal concentration at 50 population. What does it mean? They normally do it in clinical tests wherein they get a certain concentration or different concentrations of a particular substance to determine its LC50. What is LC50? Let's say they use rodents to be injected with the particular chemical. Let's say the population of the rodents, why rodents by the way? Because rodents are found to have the same physical chemical characteristics as humans, and they react to different chemicals just like humans do. So rodents or mice or rats are actually the commonly used testing animals. Now, what does LC50 mean? Let's say the population is 100. They would test at what concentration would half of the population would die. That's why it's called lethal concentration. On the other hand, if it is LD50, this time what will they do would be they will have variations of dosage of these chemicals, and then again they will find out at what dose would half of the population would die. So after identifying that, they will plot it in a curve, and then plotting it in a curve, they have to identify the threshold. So look at the figure. So here they have the reference dose, and then they plot the dose response curve. The last point or the zero probability from the curve would indicate the threshold limit. And normally, they assign a dose or a concentration that is lesser than the threshold, and this dose or concentration is what they call NOAEL. What is NOAEL? No observable adverse effect level. So this is how they do it. So they conduct the experiment, they plot the dose-response curve, they identify the minimum dose or the minimum concentration, and then from the minimum concentration, they get a lesser dosage or a lesser concentration as the threshold, as the NOAEL, in which it would serve as their limit, the no observable adverse effect level. However, using these techniques is not quite being done. Why? Because you'll be killing a lot of animals, and we know some non-government organizations and advocates of protecting the animals. And thus, we can make use of simulation to do this. So in environmental chemistry, I teach QSPR or QSAR. What is QSAR and QSPR? It's actually a methodology wherein if you know the structure of a particular chemical, you can input it or encode it in a particular software that would generate the different physical and chemical parameters or properties of this particular chemical. So in this case, you don't need to, and then they just correlate these parameters in order to compute for the NOAEL or no observable adverse effect level. Now, in this figure, you have here the different dosage or the different LD50 rather, of rats and mouse with different chemicals. Chemicals such as methyl, ethyl, ketone, pyrene, dieldrin, etc. But again, as I mentioned, they are already minimizing the utilization of this estimation technique of risk. Might as well do the simulation technique. Okay, there are factors, class, that affect toxicity of a chemical or material. What are these factors? As I mentioned, the number one factor would be the structure, because the structure or the form and innate chemical activity of a substance would determine whether it is highly toxic not only in humans but also in the environment. Of course, dosage would be another factor, the exposure routes, the species itself. By the way, when you conduct a life cycle impact assessment, the requirement for you to identify the characterization factor of a certain chemical is that you must use at least 3 phyla. So, 3 phyla that will absorb the chemical. So, for example, one species of fish, one species of algae, and one species of a certain animal. Another factor would be ability to be absorbed, its metabolism, and its distribution within the body. So for example, if one gets contaminated with the same concentration of the same chemical, it would vary if another person will be contaminated of the same dose, of the same concentration, because the other person has a different weight. That's why for nutritionists, they compute for what they call BMI or the body mass index. So that's also true for chemicals or materials which are toxic. Of course, this would also be dependent on the excretion. So, for example, antibiotics are known to be 80% excreted from your body. So that means if you drink a 5 milligram antibiotic, only 20% of which is being utilized by your body. Then the rest, it will go to your feces or urine. And then of course, the interaction of these chemicals with other present chemicals. This study of toxicity is called epidemiology study. Now, there are difficulties of doing such a study because of the following reason. Number one is difficult to match the control group. So, for example, you have identified 3 phyla. You have to establish the correlation of these 3 different species. Number two, society has become mobile, so an individual which is under study can no longer live in the same community. Therefore, the acquisition of the toxic materials will now be difficult to assess. And then number 3, death certificates typically measure only the cause of death. They do not consider the health condition of the individual, which would also justify the toxicity level of what a person has inhaled that caused his death. And then other toxicity endpoints beside death might not be measured with use of death certificates. So it's not only death that would tell you whether the substance is toxic or not. This would include miscarriages, infertility, or even learning disorder, just like with the lead. Another would be the accurate exposure data. It's very difficult to obtain because, for example, you have 100 population of mouse or mice or rats that is living in Manila. That would be different if the 100 mice or 100 rats will be living in Alaska. Then, large populations are required for these studies, and as I mentioned, some animal advocates will be very furious about knowing that these clinical studies are being done. And then, many diseases can take years to develop. So, these would make epidemiology studies very difficult to establish. Okay. There are some questions, though, that you can ask during exposure assessment. So number 1 is, what are the important sources of chemicals? So if you would observe, the succeeding questions that I will be discussing with you is the same as the questions, are almost the same as the questions you might ask yourself in identifying the biogeochemical cycle of a substance. The next question would be, what are the pathways of and routes of exposure? What amount of the chemical are people exposed to? How often are people exposed to? How much uncertainty is associated with the estimates? And what segments of society or ecosystem are more at risk? So these questions might be utilized in hazard evaluation or hazard assessment.